Hello. Hi there. Uh, so the plan for today is I'm gonna do 45 minutes, uh, 10 minutes more or less of debugging the Lisp app, going through the flow, understanding better how the app works. Then 45 minutes of Python, or 10 minutes up and down, and then 1 hour of articles and online learning. So let's start. Yesterday I didn't have my best day, not gonna lie. I didn't have my best day. I was tired. It was already late. I worked until late. So what's the name of this? Dracula. So what? Yeah. It wasn't the best of days. I didn't learn much, to be honest. But now I think I have everything here. Everything's running. So I want to debug this and understand how it works. I understand better how it works. I know how the flow behaves, but I just want to grasp it a bit better. So what I will do is, so I don't need the read. Do I need the eval? Ah, nice. So eval eval, where are you? Eval eval. Oh wait, I don't want to use Vim. I want to use NeoVim. Well, but not this one, not this one. This is the method. So what is this method doing? It returns a Lisp value. It evaluates taking an environment and a Lisp value as input. If it's a symbol, get, what is the get doing? Okay. If it's a symbol, we do this. Otherwise, if it's an S expression, we evaluate the S expression, then we return V. Okay. Okay, so this is the example I'm gonna use. This is the example I'm gonna use. But let me just see. Elval add. What is the add doing? Okay, so it decreases the count of elements in V. It reallocates data. V cell of this size. Then does this. Wait. This is what I'm gonna do. Hello. I want to follow the stack trace in C. Looking at all the methods that were triggered while, I don't know, running the app. How can I do this? Okay, I can use GDB, which is the so it's the GNU debugger. So GDB allows you to inspect a running program, view stack traces and follow function calls. Okay, I can compile it, I can run it, I can break it, I can run it. When the program pauses at a breakpoint or upon crashing, you can see the stack trace using backtrace. GDB functions. I'm gonna trigger it. Why can't I see the just a second. It's here. It's break 818. I'm gonna break here. So after all the other logic has been run. So now if I do this, no, I need to run it, sorry. I need to run the GDB, start this, then I can run it. It's here, and if my friend ChatGPT is right, I should be able to see everything with backtrace. What? How? I don't see shit. Frame 1, frame 2, what the fuck? When the program pauses at a breakpoint or upon crashing, you can see the stack trace using maybe I should use Wallgrind. I think Wallgrind is a bit better. Functions. Now if I run the same command that I have here, okay, that's it. So I'm running main. And I'm running 816, which is here. Then I'm triggering this. Just a second. How explain this stack trace, please? Why do we have to main two sources starting from the main method? Let's see. I have no idea why. So interpreting the stack trace. The stack trace captures function called memory allocations and reallocation. Wallgrind reports that reallocate was called multiple times. The program experienced an issue with memory, possibly an invalid read-write to memory, but it didn't experience any problems, right? No, it didn't experience any problems. Why are you saying that? What have I done here? No, I didn't. I wanted this. Functions. Yeah, this works. But for some reason, why does it work twice? What? Def add 2. Let me just see if this has been triggered by the way I copy things. Yeah, it has been. Okay. Let's do this again. So I'm checking Wallgrind. I'm gonna do the same thing. Def add x epsilon plus x epsilon. Okay, same thing. Why are they? Where the fuck are you here? Why are they are two identical segments. The key to understanding the repetition lies in how memory management functions like reallocate interact with the call stack. This repetition occurs because function calls leading to multiple allocations. When your program allocates or reallocates memory via reallocate, Valgrind records all active function calls leading up to the allocation. In your code, lval pop is called multiple times during different logical paths. Okay. So what happens? So we have two stack traces. Main, eval, s expression, call, lambda, pop, reallocate. Okay. Okay. So what's the first one? Main. Then we have this guy. And then this guy will trigger evaluate s expression, and then s expression will trigger lval call, and then this will trigger built-in lambda, and this will trigger lval pop, and then we will reallocate. So let me just open. Let me just open my tablet. It's here. So I'm gonna do it here. So let's think about this. Let's think about this properly. So what do I have? And how is this working? I'm hitting main. What? Sorry, no idea what happened. I didn't have my toolbar here. So what I'm hitting at line 816. I'm just gonna reduce this a bit, so at least we can see the code on the left side. Yeah, maybe like this. So first, I'm hitting main 816. It's here. Next, I'm hitting 520, which is this s expression method. Then I'm hitting 484, which is lval eval again. Then I'm hitting 507. 507. Is this 507? Which is calling call. Then call is here. If it's a built-in, return a built-in. Okay. Let's debug it. Let's debug all of this. Let me just copy this. So I have it somewhere. So I have it somewhere. I don't lose it anywhere. Okay. Why is this not properly indented? Okay, I don't need to put it in code. It will work without it. .816. So what will happen here? So what will we have? We will have the main, which will trigger lval eval. Then we will trigger lval eval s expression. Next, we will trigger elbow level again. DS expression again. Elbow call. Built-in lambda. And finally elbow pop. Is the other trace the same? I mean, eval s expression, eval elbow call, built-in lambda pop, and at the end reallocate. So let me trigger this. Let's see what happens. So functions. No, I want to debug it. GDB. Func. No, it's GDB. Functions like this. Break. I don't need the main, but I will need it at 500. Maybe not 500, maybe 513. I need another breakpoint. 484. 484. Maybe not here. Maybe. Sorry. 484. 483. 483. Another one. 520. I already did this. 507. I already did this. 615. Oops. 615. I'm gonna trigger it at the 614. 476. No. 476. 476. Gonna trigger it at 466. 466. And I have another one. 475. 476. 189. 189, but I'm triggering it where? 185. 185. And then reallocate. I think this is okay. Yeah, I think this is okay. So run. No. So let's debug this pretty simple method, but which under the hood is quite more complex. X epsilon plus x. Okay. I think I made a mistake setting up the breakpoints. Did I? 5. No, I think I didn't. Pop. Actually, I did. I should have been doing this at 192, but okay. So. What are, oops, I just forgot. I have my tablet all over this. What are the most used GDB commands? I think I asked the question yesterday. break. Wait, let me delete this side of me. This so list all breakpoints. If I type info break 185, how can I delete this? Delete 5. Okay. Continue. Where are we now? We are at 513. If I'm correct, 513 is the eval eval. 513. Yes. So. Just a second, please. Just a second. So it's def add the lambda x epsilon s arguments and plus x epsilon. So it's here. So print v is a Lisp value. Print v type. What's the type? It's 4. It's 4. 0, 1, 2, 3, 4. It's a Q expression here. So we have a Q expression. So print v count 3. Print v cell 1 type. So what's this? 0, 1, 2, 3, 4. So this is an X expression. So what's the first one? It's a symbol. So print v cell 0 symbol. It's def. What's the third one? Why can't I access? It has how many? It has 2 children. So this is the 2 type. It's 4. So where's the method that we called? So the first element is a symbol. The second element, it's a Q expression. It's this one, I assume, and I think it is. Print v cell 1 type 5 count 1 cell 0. So what's the first element? It's 2. It's a symbol. So if I print sim, what will it print out if I print out sim? What will it print out if I print out sim? Is it add? It's add. It's add. Just a second, let me get a glass of water. I'll be immediately back. And as I said, I'm back. So it's add. So the first element, how can I think about this? So V has three elements, and the type of it is, it's a Q expression. So a Q expression consisting of 3 elements, right? V type, it's a Q expression. So what will happen now? If we have, what line am I? I'm 513, so I'm here. I'm checking it if the type is a symbol. It's not. So I can go next. If it's a next expression, which is not, I can go next. and I'm gonna return it here. Three. How is it? Wait. 50, 0, 1, 2, 3, 4, 5. It's not a nice expression, right? Print v type. Print v type lol. How is this a nice expression? 4. 0, 1, 2, 3, 4. Okay. 0, 1, 2, 3. I have written them for my tablet. I have written them wrong way around. So I need to just clean this. Or I can do this like this. I'm gonna select all of these. And I'm gonna select this, move it up. What color is this? This red. Yeah. Okay. So now I cleared the confusion. So it is a nice expression. So what will happen is, where am I? I'm 520. 520. I'm hitting lval s expression. Lval eval s expression. Where is it? It's here. So now let me skip into it. I'm now at 483. Yeah, I'm here. Okay, if you have just joined, if you are watching this, basically what we are doing is I'm trying to debug the app I've been written. I'm trying to debug it to try to understand it better, so that's why I have all of this running. So where are we? We are here at line 483. So if I'm gonna print out v count, it's 3. So if I go next, print v cell I, so print I0, print v cell 0. What's the type of this? The type of this is 2. 0, 1, 2, it's a symbol. Print v cell. So basically, how do I know that this is a symbol? Because this is an enum value, the type is an enum, and I have my enum written here. I'm just gonna open my tablet again. So this is my list of enums, and I know 0, 1, 2, it's symbol. That's how I know that this symbol. I also have it written here in the app. Here. So basically, I'm just enumerating. I'm enumerating the types of the Lisp values. What have I done? Have I written something? 5 to 48. So what's the value of this symbol? It's def. So what's gonna happen now is we're gonna try to evaluate the def. So if I go to evaluate, I'm here. So if I'm gonna go next, okay, so we trigger now the level eval again. If we go next, we are hitting the environment get method. So if I go in this method, it's here. So this is the method that I'm right now in. No, I wanted to skip here. Fuck. But basically what would happen here is I would iterate through the list of environment and I would try to find the symbol that would be equal to whatever symbol we have here, and the symbol that we have here is def. So I would probably, let me just use continue. Let's see where print v type, it's 5. So now this is a less expression, v cell 0. No, sorry, print v count, print v cell 0. What's the type? It's a symbol. What is the symbol value? It's add. Okay, let's do the same thing. Let's do the same thing. So next, S expression. Is it an S expression? No, it's not. Next, I'm returning it. And where am I going further? Here. V type print v print I. So it's 1. Print v cell. The first cell type, it's 5. So 483. So what are you doing now? You are iterating through all of these and then you are evaluating them. You are evaluating them again. But considering that the first one is just the first element was a built-in method, which was masqueraded as a def keyword. The second one is a Q expression, and the third one, we sell to, what's the type of this? It's 4. Print we sell to, it's 4. So what's 4? It's a NES expression. Count, it has 2 elements. Cell 0, what is the type of this? No, let me follow this. So what will happen here is I'll go next. So I'm hitting the eval. I can step into it, considering that this element is not a symbol. We're gonna skip this. Consider that the element is not a nested expression. It's gonna skip it. So it's gonna return it. Oops. 520. 520, where are you? 520. Ah, you are here. It's 4. So now I can skip into it. Now I will print count. It has 3 elements. So what's the first element? The first element is a symbol What's the second element? Type. It's a NES expression. Okay. Where am I? Where am I in the code? I'm here. 483. So 483. What will happen now? Next, I'm evaluating this. So next. Next, 483. Is there a skip? No, I have continue. What finish? Continue. So I have another breakpoint. So this is gonna be an X, yeah. And the second one is gonna be an epsilon. Okay, so where are we now? 513. I'm here. So next, it is a symbol. No. Print v type. Okay, continue. Print v type. It's 5. Continue. So I'm here now at 614. It's a function. It's a built-in lambda function. If I go next, it's gonna return the built-in 615. It's gonna return where is 615? It's here, so it's gonna return the built-in. A built-in consisting of two elements, and I assume that the first one type is a co-expression. So this is gonna be X. This is gonna be epsilon. Oh, sorry. This is gonna be epsilon. I assume the second element. So 615. But where did it build this function? That's what I'm interested in. Where does it build it? Because I'm here. I'm here. Where do you build this guy? Okay, for those of you, I had a lot of viewers at one point. I don't have them anymore. But if anyone is watching, what I'm trying to do, what I'm trying to understand is, let me just show you. Maybe this is gonna be the best way. I have this structure, which is a way to define functions in our Lisp-like language. So I want to see how did we actually create a Lisp function, a Lisp type of function by providing all of these special keywords. That's my point. Let me just turn this off. Okay, I'm trying to understand how this works, and I'm trying to understand how this works, but it doesn't fit in my head. I want to know how the built-in is created. That's what I want to know. So if I lol call, where's the next instance? It's here. Ah, so it's here. Here we actually where are my constructors? I want to see where the constructors are being called. Lol fun. Add built-in. Okay. So it's most probably done here somewhere. But still, how do I print a type? So what's A? So A is a function. 614. 614. Fuck me. 614. Okay. So if anyone is watching this, what I'm doing is I'm trying to debug. I'm trying to understand why and how this structure, which I wrote as an input. Where's my pen? Here. How this gets transpiled or converted into a function. As you see, this is the input, and as you see here, we are in the method. Where are you? Lol call here, and it treats my Lisp value as a built-in method. So, which I assume is this. Is it lambda or def? I think it's def. Wait, let me just check. Built-in lambda. No, sorry. Let me just check it. Where are the constructors? They are here. Okay, so it's not a lambda, it's a function. It's a predefined function that we have in our application. So 615. Return the built-in. Okay, what if I do continue? Built-in lambda 467. No, 467. Where are you? You are here. Built-in lambda. So what do I have here? I have A. It's a function. It's a function. And the function has the following structure. It has a built-in method. It has, oh god, it has the Lisp environment, right? It has the formals and it has the body. Mm-hmm, 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 mm-hmm. Okay. What are my formals? Formal for another list value. So print a formals count. Why can't I access it? Why can't I access this? Have I created them even? Seven one. I still haven't created them. Wait. Print a count. I have. Okay, my mic was off for a moment there. So I have two elements here. So the first one, well, 0. The first one is a Q expression. So it most probably is just the list of my arguments. So if I do this, if I check the first element so this is my Lisp value. My Lisp value is a function. Now my function consists of two elements, as you can see here. So because my Lisp value consists of two functions, right? Sorry, of two elements. I assume that the first element is the list of arguments, which I'm gonna test like this. If the symbol is sex, yeah, definitely. Now the second thing, the second cell, I think it's another, yeah, it's another S expression. And now this one, cell 0. The second one, how many elements does it have? 0. So the second one is a symbol. It only consists of plus. And it only consists of plus. How does this even work? Print a cell. The first element, cell. The second element, type. Okay. Hi, for everyone for anyone who's watching this, I'm trying to debug. I'm trying to debug a command that I added in here. Let me just show you. So this is the way we define functions in this Lisp-like language I've created. So what I'm trying to do is to understand how this gets converted into a function in Lisp, in this version of Lisp-like language. So currently I arrived here. I arrived inside a built-in lambda, which creates and builds a built-in method. And basically here is where the magic happens, because here we are popping the formals, which are the arguments of the method right here. And after that, we are popping the body. So actually I can do this. Where am I? Next, I think this is okay. Oh, it's triggering again. Next. Okay, next. Now formals. No. Print formals. Print formals cell 0 symbol. It's X. Yeah. And what X is this? It's the X. Let me just also print out the first element and the epsilon. So those are these two elements. These are the arguments from here. Now, let me see the body. Next, Oh, I'm just gonna turn this off. Next, print body count. It's 3. It's 3. It's 3. So if I do print body, the first element, and the type, it's a symbol. If I do the symbol, it's a plus. The first element is X, and the second element will be epsilon. Okay. Okay. So I have the body as well. I have both the body and both the body and the formals. So now if I do continue, 614, print f. Is it 4? It's 3. Print. So what's 3? 0, 1, 2. It's a function. It's a formal function. So if I go next, and if I go skip into it, so I'm returning the def. So if I go next, if I go continue, that's it. Okay, I think I understood how this works. I still have holes in my understanding, but I think I have a good grasp of it now. I think I'm ready to start the next chapter next time. Okay. Okay. Now, I wanted to do something else. I think I'm good with this. Now, how does this work? Like this? Okay. I'm good. I'm doing well. I think we will continue in the next episode. I think I have a good grasp of it. And in the next episode, I think we are starting conditionals. So see you in the next one regarding C. But now I want to do something else. And that's something else. It's called Python. It's called Python. So let me close this. Close. Let me also close this. Okay. So I'm here in my projects. I'm gonna create Python folder. Let me then do something else, and that other thing is called how to create a Python env virtual environment. So why do I need a virtual environment? Because in the case I'm going to use pip or I don't know, some other things, I want to, manage properties, manage dependencies, have everything encapsulated in different environments. So that's the reason why I'm creating a virtual environment. Initially, I had no idea how. I think I have this. Python version. Python. It's like this. How to Python 3. Okay, I have Python already installed. So what I'm gonna do, I'm gonna set up Python now, create a virtual environment. Yeah, it's like this. It's like this. The virtual environment was not created successfully because ensure pip is not available on Debian Ubuntu systems. You need to install the Python 3 venv package using the following command. Okay, let's do this, but Python venv. I will install it without any specific version here. Will this work? Yeah. Unable to locate. Fuck. So do I need to do 3.12? Okay, this works for some reason. Okay, now if I try setting up a virtual environment, it should work. Let me do this again. So I haven't also worked in Python in a long time, probably since university. Okay, so I think, how do I run it? I go source env bin activate, and I'm here. I can touch, and I'm gonna call this functions py, and then I'm gonna enter functions py like this. Python 3 source. Yeah, I think I did. Yeah. So this is the problem that I had. Ensure that virtual environment package is installed. If you encounter a module not found there, I should install venv. But the problem is, what's the problem here? Have I messed up if I installed 3.12? I don't think I messed up. So what I will do now is I'm going to talk about functions now. And in relation to this, let me do the following. Page settings, give me black. 160. Oh, sorry, I'm not. Okay. No, not functions. I want Python. Python, but not functions. Just Python. Okay. So we have this now. What's the size of this? Let's do 20. So Python functions. Defining functions. Okay, so what do we have? Define functions using the def statement. These are cornerstone of all programs. So what I'm gonna do, I'm following a book, a great book called Python Cookbook, which has a whole chapter dedicated to the idea of functions. So what I'm gonna do is try to do and present some function definitions and usage patterns. So what we will do here, functions that accept any number of input arguments. Okay. Okay. So how can we write these functions? Like this. Input def multiply first def sum. Let's do the sum. So first, then I'm using the rest. The rest is basically similar to the variable arguments that we implemented in the Lisp-like language there. So what I'm gonna do is return first plus sum of the rest. So if I do sum 1 and 2, if I do sum 1, 2, 3, 4, 5, if I do sum 1, 2, 3, 4, 5, 6, maybe I should just print this as well. Print, how do I print in Python? How do you print in Python? What I also wanted to do, because I'm just following books here, I'm learning on my own. I wanted, after I gain enough knowledge and insight, I wanted to so it's print first plus sum. I wanted to create a project of my own. So hopefully let's see why this doesn't work. Why are you not working, my friend? What is happening with you here? Maximum recursion depth exceeded. So what is here? The asterisk should help us write a function that accepts any number of positional arguments. That's why we put an asterisk here. And this is how it works. But for some reason, I get an error saying previous line repeated 99. Why? Sum 1 and 2. So wait, why is this one not working? Why is this one not working? Can you tell me, please? Why are you not working? Ah, I'm an idiot. Okay, so I'm gonna call this one sum rest. Let's do it like this. So next, oh, actually this is gonna be a good exercise in Vim. How do you select and replace text in multiple lines? Let's see. You can select. I don't want to use visual mode. If I'm using Vim, why would I use visual mode? I'm using Vim for one reason and one reason only, because I want to act smug in front of other developers who are using IDEs with colors and shit like that. I'm using Vim, bitch. Sorry. Yeah, I'm using fucking Vim. At one point, I actually had 4 people watching the stream. 4 people wasting their time. Now we have 2 or 3. Okay. Okay, so this is the visual mode. I'm not interested in all. Without selecting. Now, this is what I want. This is what I want. This is what I want. 5, 6, 7. So how do I do this? So I have this S. So sum is gonna be sum rest. But no. Wait. I want to replace from line 5 to line 7. And it also says here to use the G keyword. I have no idea why. No idea why. I think this is gonna work. This is gonna work just nicely. Nice. Nice. I wrote leave this. Like, there's nothing triggering me more than the fact that every time I open a new tab, I open a new split tab. Sorry, I need to change my theme to the one that I'm using. Like, nothing triggers me more than this. I need to find a way how to fix this. Now Vim functions. Okay, so this is the first thing. I can delete this. Nice. I can delete this. Just a second. So, what's the next thing? So, what is the rest? Rest is a tuple of all the extra arguments that we passed. And the code will treat it as a sequence in performing calculations. But what if we want keyword arguments? What if we want keyword arguments? Let's do this now. So let's do this. Import HTML. It seems that we will have to install it, but I'm gonna think about it when the time comes. Now, make element name value. So what's the difference between 1 asterisk and why am I opening this between 1 asterisk and multiple asterisks? I have no idea. keywords. So what do I have here? S item for item in attribute items. So what is happening here? Attribute string, it's an empty string, and I'm joining these keywords. So what's happening here? This is a string equals, what's this one doing? Okay, let me just finish writing this method and then I'll try to make sense of this. For item in attribute items, which is this keyword arguments. So I'm taking this keyword argument and I'm doing something with it, which is a string manipulation, I assume. Then I'm joining it. Let's see. Return element is equal name attributes value. Then I'm closing the name. Then I'm formatting this. Name is equals name. Attributes is attribute string. Value is HTML escape value. I'm returning the element. Saving this. So first of all, let me understand what is happening here. What is happening here? Please explain me this method. Let's walk through the code you provided line by line to understand what the make element function does. So this function generates an HTML element as a string with customizable tag names, values, and attributes. This is what happens inside. So this is the name, which is the name of the HTML element. This is the value, which is the text that's found inside the element. And now these are attributes, a variable number of keyword arguments. So these are keyword arguments, which represent HTML attributes like ID, class, etc. These attributes are passed as key value pairs. Okay, next. So what's happening here? So attribute items is gonna give us a list of key value tuples for all attributes. Okay, so if we have a key of, I don't know, ID equals element ID, so this is gonna, the items will gonna give us these tuples. Now list comprehension is used to format each key value pair into strings like class. Ah, okay, so this happens. The key value pair, the tuple, is gonna get extracted into this string sentence here. So if I have this class, my class, ID main, Yeah, this is what's happening. Class is gonna be my class, and ID is gonna be main. Okay. And then we are joining this. This join sole attribute string is into a single string. Class my class, ID main, and then I'm creating the final elements. So the format is used to insert parameters into an HTML string. Okay. So this is gonna become, and then I'm returning the element. Okay, so let's see how this works. Let's see how this works. How this works. Make element. Can I print them? I should print them. No, I'm gonna print them above. Make element b span make element item a house size large quantity 6 save and now if I run this invalid syntax. What's invalid here? I know what's invalid. I forgot to put this here. Okay, I have a bug here. A bug that's caused because I haven't put this here. I haven't done this. So what are these? This is how we format strings in Python, it seems. Again, I have no idea how this is done. String format is used to insert the parameters into an HTML string. So this is gonna become something like this. Let's test this. Let's test this and let's print this. Okay, so I have P, which is the beginning and closing element, which is the name of the element. I have item, I have divs, which works. So how this works based on the last example here. I provided the name of the element and I provided the value of the element. So this is the name, this is the value. Now the problem is how are we gonna extract these keyword arguments? I'm iterating through all of them. Here I'm using the list comprehension in order to get both the key and the value pair. So this is the key, this is the value. Then I'm joining them together on an empty string. Then I'm just pumping them here using the attribute value. Okay. So attributes is a dictionary. This is a dictionary that holds the keyword arguments that we pass, if we have any. It holds these arguments, or these, or any others, if we have them. Can we, now here is the question, can we create a function that holds both positional and keyword only arguments? I think we can. I think we can if we do something like this. Def both arguments. I can do this and I can do this. Print arguments. Oops. Print keyword arguments. So what happens here is that all positional arguments will be placed into a tuple arguments, and all of the keyword arguments are placed into a dictionary keyword arguments. So these are the extra notes that we have here. This element can only appear as the last positional argument in a function definition. So you can't allow any regular arguments to appear after this. It can appear before the keyword arguments, but it needs to appear as the last positional argument. And this guy can only appear as the last argument, period. So arguments can still appear even after a positional arguments. So this is fine. X, this is fine. This is fine as well. Okay, interesting. So yeah, I wanted to say, most probably in a month, I think if I keep on writing these every day, I hope in a month I can start writing my own project, something of my own, something of value, like a video game maybe, or I don't know if you heard about this. Let me try to find this. Okay, let's do this after I finish everything here. What's the next thing to do? So we want a function to only accept certain arguments by keyword. How? I have no idea. If you place the keyword argument after wait, I have this piece of code, but I have no idea how this works. How is this one? So this is a keyword only argument. This is enforced using the asterisk in the function signature. So what happens here? this in the function signature makes the arguments following it, in this case block keyword only. This means you must provide block using a keyword argument when calling the function. How? Why? Okay, interesting. So what happens here is, how do I keyword only arguments? So if I do def keyword only size this block print size and block. So if I do now keyword only, if I do this and true, what will happen here? Let me save this, sorry. Keyword only takes one positional argument, but two are given. But if I do block equals true, it's here. Wait, let me just delete this. So is this just syntactical sugar? Why? This is just something to remember, most probably. Yeah, I think it is. So this happens, where are you? Here. The keyword only argument happens when we want to have keyword arguments after this asterisk symbol. Is this asterisk? I think it is. So why do we use keyword only arguments? Most probably for greater code clarity when specifying optional functional arguments. So if you don't know how the code works, if someone doesn't know how a certain code works, I assume, we would have no idea what certain arguments mean. So if we force the user to, not the user, the programmer, if you force him or them to have a code that is written like this, it is a lot clearer and a lot more understandable what happens here. Okay. How long am I streaming? Let me check. I'm sorry. 1.5 hours already. Yeah. Okay. For those of you who just joined, I did already the first hour. I worked on the Lisp program that we are building. I was debugging it. I was trying to understand how the flow works because at one point it became too complex and I basically got lost. Now I'm just doing, I don't know, you like, these are really simple things. I'm mostly a front-end developer, but even I can understand how and why some of these things work. I mean, the syntax is a bit different. I have no idea how the list I had no idea how the list comprehension behaves, but after reading about it, you know, it's clear. In the end, most programming languages are just synthetic sugar on top of whatever you are writing, on top of registers closing and opening. Yeah, but one thing, I think, should I wrap it up or? Yeah, let's wrap it up. I just wanted to show you this. Most probably, I'm gonna start one of these tutorials. Maybe I have no idea what exactly, but definitely I plan on doing this. Build your own Lisp. Yeah, I'm already following this, so it's gonna be okay. Let me just do something else. Hey, thank you. Compilation Kings, thank you. I have hundreds of tabs and windows open, so sometimes I just miss comments on the videos, but thank you, I appreciate it. Let me just do one more thing. Functions. So what am I doing here? So I want to make functions more clear. I want to show additional information. I want to say what type of data are we providing, and we want to annotate our function. So how can we do this? Let me go all the way to the bottom. Like here. So how can I do this? I can create a function with additional information like this. It's just like TypeScript. Yeah, I like to compare everything to TypeScript. After working with C for the last, like, what, 1.5 months, I can say without doubt that TypeScript is a lot more intuitive, which it makes sense, you know. It has been developed in the last, when was TypeScript released? When was TypeScript released? 2012. Yeah, I wanted to say in 2014 or 12, compared to C, which was released what, in 1972. So it's obvious that one language will have certain domains and ways of thinking that are much more clearer and straightforward for a human than C, which in the end C is just glorified assembly programming, in my opinion. It's great. You know, compared to whatever we had before, it's wonderful, it's intuitive and everything, but it still urges you to think like a computer when you're writing it, which may be even better. Who knows? So yeah, I wanted to talk about this. So we are annotating our methods in order to give information about how we should use the functions. So if you have this, we know that x is an integer, that epsilon is an integer, and that we return an integer here. So what happens is that Python actually doesn't attach any meaning to this. They do, these annotations don't make Python behave any differently than it did before, but they are giving additional information to the developers, to the programmers. They give semantic meaning to the methods that we create. And where are these stored? These are stored in the annotations. So if I do this, print add annotations, and if I save this, and if I run this, yeah, here I have it. So x is of type integer, epsilon is of type integer, the return type is of type integer. Where's just this guy? I want to print size block. Pass. Okay. So yeah, and the primarily reason of why we use annotations is because we want to document their meaning. I mean, in this case, we just write a simple stupid function, but in more complex cases, in code bases that span hundreds of thousands or millions of lines, like this can be really useful. You know, especially because Python doesn't have a built-in type declarations. So annotations are helpful and they guide the developer in the dark. Okay, so I think I'm gonna end it here. The stream, that is. I want to thank you all for watching. I want to thank you all for listening. I had 40 views. Wow. Thank you. Thank you so much. I would like to continue, but it seems that the Red Bull I drank this morning, that I drank like 1 hour ago, is wearing off. So I'm becoming a bit more tired. Thank you so much. Unfortunately, I won't make the 1 hour of articles. What have I done here? Yeah, I won't make 1 hour of articles today. I'm gonna make it some other time. So thank you all, and see you in the next episode.